this video, we'll see a nice theorem called the Cayley Hamilton theorem. We'll see an example as well. Alright, so I'm going to assume I have a square matrix and then I know its characteristic polynomial. So let's say its characteristic polynomial is a to the n xn plus a n minus 1 xn minus 1 plus a1x plus a0. Alright, so that's the characteristic polynomial that you got from computing some determinant. Then, if instead of x in the characteristic polynomial, if instead of a real number, if you plug in a matrix, you'll get a matrix out of it, and then if you plug in a, you'll get the zero matrix. So then PA applied to A. Let me spell out what this means. It means you take AN multiplied by the nth power of A and so on. If I leave it like that, it doesn't make sense. It doesn't make sense because every term is a matrix except for the final one, which is just a real number. To make sure everything is a matrix, I'm going to multiply the final one by the identity matrix of the right size. And so that gives you the zero matrix. All right, so let's do an example. I'm going to spell this out for a specific matrix. So I'm going to take A to be 2, 1, 5, 3. And I'm going to check that the Cayley Hamilton theorem is true for it. Alright, so I'm going to start by finding its characteristic polynomial, then I'll plug A into it. Alright, so I'm going to get the determinant of 2 minus x, 1, 5, 3 minus x. I'll get 2 minus x, 3 minus x, minus 5. Let me multiply it out so we can easily plug in A. So I'll get x squared minus 5x plus 6 minus 5. So I get x squared minus 5x plus 1. Alright, so that's the characteristic polynomial that we've been using to find eigenvalues. I'm not after eigenvalues at this point. What I want to do is plug in A and check that we do get the zero matrix. So I want PA of A, which will be A squared minus 5 times A. Remember to add in the identity, plus 1 times I2. And I want to make sure that I get this 0 2 by 2 matrix. Alright, so P of A would be the matrix 2, 1, 5, 3 multiplied by the matrix 2, 1, 5, 3. Then I'm going to subtract 5 times 2, 1, 5, 3. And I'm going to take plus the identity matrix times 1, so the identity matrix. 4 plus 5, 2 plus 3, 10 plus 15, 5 plus 9. Alright, so I get that A squared is 9, 5, 25, 14. Then I want to subtract 10, 5, 25, 15, and add 1, 0, 0, 1. Alright, so let's check each entry. For the top entry, I get 9 minus 10, which is minus 1, plus 1, I get 0. Then I get 5 minus 5 plus 0. 25 minus 25 plus 0. 14 minus 15, that's minus 1 plus 1. I do get 0.